So, using Kriya-Haring we will derive equation of motion for a single triad. Okay. So, this is not for general triad, but a single triad. Well, general means multiple triads. I will do for single triad. There is a reason for it, why I am focusing on a single triad. Okay. So, this picture again, please focus on this picture. So, I have 3 wave numbers k prime, p and q, and my condition is that k prime plus p plus q is 0. So, these are 3 vectors like this and this okay, k prime, p, q. Is that clear? So, now remember I had said for convolution k equal to p plus q. So, any product f g, if I do the Fourier transform of this one f t, I am looking for k, there is this convolution f of p, g of q, and this also works for cross product, dot product, So, because cross product, dot products involves sum of products. So, the condition is k equal to p plus q. Now, it is not symmetric, no. So, if I use this definition, then p is equal to k minus p, sorry, k minus q, q is k minus p. So, they are not symmetric, k acts like a boss, so p plus q. So, I want to make it symmetric. So, all of them equal footing. So, one good idea would be to use this called minus k prime. So, k is equal to minus k prime. Then k prime plus p plus q is 0. Now, all of them are in same footing. So, k prime is minus p minus q, p is minus k prime minus q, and q is minus k prime minus p. Okay. So, they are all, nobody is boss, they are all equal. And please remember, they must add up to 0, vector addition. That means each component must add up to 0. Now, this k, p, q are 3 dimensional, could be 3D vectors, but whatever 3D vectors they may be, k, p, q will form a plane, right, because of this condition. So, you can see, visually see, they will form a plane. Okay. So, k, p, so any 2 vectors form a plane, but third one, because the third one is minus first minus second, so they will be in the same plane. So, they form a plane. So, I am going to use my 2D ideas to solve this problem. Okay. So, basically we can use 2D physics to work out equation of motion. It simplifies a lot, and a lot of times we are working with single triad. So, this idea will work for a single triad, but for other triad you want to do it, then you have to work only for that particular triad, and I will show one example how to deal with it, but this technology may not work. You may have to use n vector. So, this technology may not work all the time, it is true, it may not work, but if you have single triad, this works beautifully. Okay. So, let us focus on single triad. Okay. So, we will worry about this technology as and when it is required. So, I will choose n cap. So, I need n cap, I want to use Kriya-Haring, that means I need n cap, without that I can't proceed. So, n cap uses q cross p. So, q is coming this way, q cross p. So, q cross will be perpendicular to the plane, above the plane, like this. So, this is n cap. Now, we can construct E1, E2, E3 or E1, E1, E2, E3 for each k vector. So, let us worry about k prime. Yes.
N cap is different from the n cap that we used in deriving E3 previously.
No, it is the same thing. So, that time we did for single k. Now, for single k, I said you can choose any k, right. So, that was k vector, and I was choosing n cap, then I could make E1, E2, E3. But now we have 3 vectors. I want to choose a n cap which is perpendicular to this plane. So, the advantage will become clear in a minute. Okay. But you are doing it for all 3 of them, a single n cap, and that is why I think his question also makes relevant. If I have 4 vectors or 5 vectors, then this idea will not work. Okay. But let us not confuse too many things. Okay. Just single triad, and we will work with this. So, now this k vector, k prime vector. What is E3 for this k prime vector? Is in the direction of k prime. So, this is my E3 k prime. Yes. What about E1? K cross n. So, k cross n. So, my k vector is like this, k cross n. So, which way E1 moves? Screw moves, right hand screw moves along this direction. So, this is my E1 k prime. What about E2? E3 cross E1 into the plane. So, my E2 is downward of k prime, only k prime. Okay. So, I have done for k prime. What about P? Do the same thing. So, P cross n. So, this P cross n. So, this will be E1 P. What about E2? Into the plane, E2 P. So, I have written here E2 P is minus n cap, E2 k prime is minus n cap. Same thing with Q. In fact, you do not need to do this algebra all the time, or you do not keep moving the screws. So, if you just see the direction of vector, right hand side. So, the road going towards the right, take right. So, if you take right, then you will find E1. It is easy to see from here. So, E1 is k vector, I am going along k prime, take right, E1 k prime. For P, right, and Q. So, the Q is going this way, but please keep in mind that they are going clockwise. If it is counterclockwise, then there is a problem, there is something else. So, the technology is you have to be careful with this. So, this for clockwise, you arrange your vectors clock 12, 1, 2 like this clockwise. Okay. So, these are tips I am giving you. Now, we can work with counterclockwise, but some sign changes happen. Is that fine? So, if I choose I have a triad, I choose my n cap, which is Q cross P, and then I can construct E1, E2, E3, and I am ready for the next step. Okay. So, this picture you have to unfortunately, so I repeat this picture here. Now, I need the dot products. You will need this in the next slide. Okay. So, you can take the dot. So, this E3 is in that direction, E3 k prime. So, by the way, for E3 dot E1 k prime is 0, they are mutually orthogonal, but I need dot products of E3 k prime with the E1 p. So, this one and E1 p, this one. Now, this table you can just construct. Now, this is just bit of work, but I have done this. You can use this numbers. So, I need angles. So, alpha, beta, gamma. Now, this again is standard notation. In front of k prime, the angle is called alpha. This is front of k prime. In front of P, angle is called beta, and in front of Q is angle is called gamma. So, alpha, beta, gamma, k prime, P, Q. So, k prime front is alpha, P front is beta, and gamma in front of Q. Now, this dot product I will not ask you to do, I mean you can do it yourself, but I will not do it here. Okay. So, E3 cross E1. So, this E3, E1 will be in that direction. Now, this angle is gamma. So, you do this. So, you will get minus sin gamma. So, there are quite a few zeros, and there are, so we need, so by the way, with E2 everything is 0, E2 is downward. So, E2 dot E3 is 0, E2 dot E1 is 0. So, that is a simplification for a triad. So, you will have only E3 dot E1 and E1 dot E1. Now, this is algebra. Okay. So, but I will, so let us look at the next slide. Okay. Now, we are getting ready for the deriving equation of motion. So, UK dot. So, there is only one triad. So, this is a convolution, no. So, nonlinear term, you worry about the nonlinear term. What is the nonlinear term? Minus I k dot UQ UP. is there on the notes, chapter 9. That is what you should look, chapter 9, this in more detail. So, but there are, so you see I have k prime. So, this is for uk dot, nonlinear term, worry about the nonlinear term. But now I put k prime dot. So, you see k prime dot. So, k equal to p plus q for this one. No? What was k equal to? It was p plus q. So, what is k prime? Minus p minus q. So, when I write uk prime, because I want to treat them symmetric, so I have to write down for uk prime will be minus p minus q. So, instead of q I have to put minus q, and instead of p I have to put minus p here, and this is a pressure gradient. Viscous term, don't worry about it. If you write, well, I mean, let's not worry about it right now. Is that fine? This equation is okay. So, instead of k equal to p plus q, I am using k prime is minus p minus q. Now, take a dot product of this one with E1, dot product of the whole equation with E1 of k prime. Now, E1 of k prime does not change with time, it changes with k prime, but if I choose my k vectors elsewhere, but even k prime does not change with time. So, this can go inside. Is an important thing to keep in mind. No? My basis vectors are fixed in time. So, I will get k1 uk prime dot E1 k prime. What is that? That is u1, this guy. Dot means d by dt. Just focus on the steps. I mean, this notes is there in the notes, but I will give you the PPT. Okay, today I will pass it on. Just look at the steps. Now, I want to compute this. So, I have minus I k prime dot u minus q. Now,
k prime is not changing.
K prime is not changing with time. In fact, for a given triad, k prime is fixed. So, example you can think of triad is 0 1, 1 0 1 1. These are wave numbers, no? So, wave numbers do not change with time. Amplitude of the Fourier thing changes with time. So, what is the k prime dot u of minus q? So, let us look at this one. Okay. So, just focus on this. K prime is k prime magnitude E3 k prime is, it has only a long component along E3. Now, this u of minus q has component along u1 and u2, but what about u2 component? 0, because u2 I know e2 is perpendicular. So, that is simplification. Okay. When I choose this triad, it goes to 0. Before getting into algebra, so I am going to write this as u star of q vector, u star of p vector. Okay, please allow me this. Okay, this I set reality condition, so this is gone. Now, what is u star of q? It has two components, u star of E1 q1 plus u2 star q E2 of q, correct? So, but this dot product is 0. So, this is gone. You are left with E3 k prime dot E1 q, and there is a magnitude, there is an amplitude coming E1 star q. Okay. Now, I can see that from the table, no, E3 k prime E1 q, that is why I gave the table, and that is true for any triad. So, because alpha, beta, gamma can be already calculated from a triangle. So, this number, in fact, this is sin beta. Now, I will not go back and look at the table. So, E3 k prime dot E1 q, if you do not believe me, so I can go back. Well, I will not go back because this will. So, this is minus sin beta. So, minus I k prime sin beta. So, this is what we got. Now, take a dot product of this E1 k I want, no. So, this is u star p. So, what you got is u star of p vector dot E1 of k prime. Now, u star p, this one has component along u1 and E1 and E2, but u2 component goes to 0 anyway. So, you are left with E1 p dot E1 k prime, right. E1 k prime from here, E1 p will come from here, and what is the amplitude will come in front? u1 star of p. So, u star p will come from here and u1 star q has come from here. You can see a word. So, this is simple. Is everybody following me? So, no. So, let us go back. So, I am computing this term. So, u of minus q I replace by u star of q, number 1. Okay. So, I first do this one and do this one. So, now I am, so I want to compute u k prime dot u1 q prime, u star q, sorry, u star q. So, u star q is u1 star q e1 q plus u2 star q u2 q, and this is just a vector. Now, I know that E3 dot E2 is 0 for any E2, all the E2s are downward, E3 is in the plane, E1 is in the plane. So, that is gone. So, I get E3 dot E1 q dot product, that is sin beta. Fine, everybody happy? Amplitude E1 q is coming here. No, E3 k prime and E1 q, E1 q, not same. That is why you write the argument. I am telling you the arguments are important. So, is that now? So, you have computed this part. Okay. Now, this algebra, if you recall, computing n cap was quite involved. You know, I had ux, uy. So, it is just straightforward. You see. Now, u of minus p, I am taking a dot product. This guy comes dot product with this. So, I get here u star p dot E1 k prime. So, u star p is again u1 p. So, this I write as u1 star p E1 p plus u2 star p E2 p dot product with E1 q E1 k prime. So, E1 k prime dot product with E2 p is 0. So, this is gone. So, you are left with E1 k prime dot E1 p. So, this is what I got here, and U1 p has come here. Okay. So, this you just reproducing, just doing it carefully, and there are few dot products, but that you take from the table. Okay. Now, you can do the same thing for the second term. Okay. And what about, okay, second term I will show you the result in a minute. What about this term? Minus ik pk dot E1 k prime, 0, because this is along E3 cap k prime and E1 k, so particular. So, pressure goes away automatically. So, you do not need to compute pressure. Okay. So, if you do this algebra, so this is next step is this one. Now, this E1 p dot E1 k prime is from the table. So, that this is a table I computed, just read from the table. Okay. So, there are two angles, product of two sine cosine. So, this is cos gamma and this is cos beta. So, I get basically sin beta minus gamma, this is it. Okay. Now, I am happy with this, so I do not know whether you are happy with this. So, all that algebra which we did is just coming from the triangle angles of the triangle. Okay. And using this you will see that it is doable in 5 minutes. That algebra, which is long one, can be done in just few minutes. Now, this for E1, U1. Now, let us do for U2. Now, U2 will be simpler or complicated, more complex. Oh, great, this guy is very clever. So, you just take this thing and dot product with E2. So, I take a dot product with the whole thing again. So, I want to change the color to red. So, dot product this whole thing by E2 k prime dot. So, this one is pressure is again gone, right. E2 k prime is perpendicular to E3 k prime. So, this will give you U2 dot of k prime. Now, so this you do not need to recompute. K prime dot u of minus q is same as before. The product does not change. Only thing you need to worry about this u of minus p dot u2 k prime. So, I have few steps I think written. So, instead of product of E1, Now you have u2p dot u2k prime. Remember this was, well, this is easy. So this is u2 star of p dot vector e2, no, not u2, right, up, okay, dot e2 of k prime. This what is going to come, right, from the dot product. Now what is u star of p? Now it has u1 component and u2 component. What about u1 component dot u2 component? 0, because u1 and u2 for all vectors are 0, for all. So only thing which will give you component is u2 component. So u2 star of p, e2 of p dot e2 of k prime. And what is u2p dot u2k prime? u2 is always along minus z direction, so it is 1. So u2, I can close my eyes and just, you don't need to read from the table. u2 dot u2 for any pair is 1. So this becomes 1. So that is simpler. There's only a step which is simpler, otherwise. So this is exactly same as what I did in the previous slide. Now this for the first part. Now I can do the second part, which is just that. So these guys are 1, these also 1. So you can just put them together. Okay. So my u2k prime is this. Now of course you done it only for one of them. So you do for u2 of u of p and u of q. So there are 6 equations: u1 u2 for k prime, u1 u2 for p, and u1 u2 for q. Okay. Now you please reproduce one of them. Well, reproduce for u1, and I have done work. So you can look from the book. So what is for p and what is from q. So we will again go back to our old example, this triangle example. This is that cos y. So this one I solved it in the last class, yes, in Friday's class. So our idea is to find b dot, c dot, and a dot. Now they form a triad. The two triads. So cos y is, so now some of you, if you are lost, then this is another time to regroup, kind of understand. So this is 2 cos x is e power I x plus e power minus I x. I am absorbing 2, okay. So it is kx is 1, ky is 0. It is a 2D. So this is 1 0 and there is a minus 1 0. So in fact if I draw the vector, these are the two vectors. So this x axis, y axis. So this one gives you 0 1 and minus 1 0. So this is 0 1 and minus 1 0. This is another vector. Third vector is in that direction. Now, so how many triads are there? So there are interactions among them. So these, I am sorry, I forgot this minus 1. So there is a 1 1 here, 1 comma 1. So there will be like this and there will be like this. So I want to make the closed loop. So k equal to p plus q is not symmetric. So we want to make this k prime plus p plus q is closed. So that is why I want to. So you can see that they are exactly opposite of this, and it turns out that equation for this is identical to equation for this, because they are complex conjugate of each other. For this structure, okay, right now my flow has symmetry. 1 0 and 0 1 are symmetric, either same or complex conjugate. So it is the simplest nonlinear problem. Is that clear or not clear, everyone? So this one, this has C and this has C. You see? So this is, now let us find u1. Now I wrote this u1, but I need to tell you how to get this. So u1 is along 1 0, no? So I will draw again, okay. So 1 0 is this. Now 1 0 here, so it is magnitude is along y direction, right? What is the direction for 1 0? My vector is c y cap. This I did in the last class, okay. But what is my direction of E1 vector? I told one clue: go along the vector, turn right. So this is my direction of E1 of 1 0. So, they are opposite, no. So, my unit vector is downward, my vector is along upward. So, there is a minus sign. What about 0 1? 0 1 is coming from here cos y. So, it is e to power y plus e to power minus y y. So, my vector is b x cap. So, this vector is b x cap. So, what is the direction of E1 for this vector? X cap, turn right. So, that is why it is positive sign b. Okay, so, now we need some more space for 1 1. Now, 1 1 vector is like this. Now, this one you have to do more carefully. So, I write this 2a e to power I x plus y plus e to power minus, no minus, right, minus I x plus y by I. So, I am going to pull it out and 2 is absorbed. So, what is now this is x cap minus y cap. So, I rewrote this in terms of exponentials. So, 1 1 is here, this is 1 1, right. So, Fourier amplitude will be this guy for 1 1. So, what is Fourier amplitude? It has x component as well as y component. So, x component is a by I, right, x cap, this one, fine. What y component is negative, y component minus a by I. The resultant vector is in that direction. So, it is a root 2 by I, its magnitude is a root 2 by I, fine. So, this for 1 1. What about minus 1 minus 1? Complex conjugate. So, this will be a root 2 by I minus. So, this vector is in that direction. There is a minus sign sitting here, you can see that actually. Is that clear? So, of course, you have to be just careful, but this is straightforward, okay. Just it is a labor, that is why I said you have to do it carefully. So, this is why minus 1 is minus a root 2 by I, okay. Now, this is my triangle. So, this I call it k prime, my notation is, do I write k prime? So, let us just take this from here. I put them as x y z, k p q. This will follow the same thing notation. Okay, this I call it p and this I call it q. So, k prime plus p plus q is 1, 0, sorry, k prime plus p plus q is, these are vectors, no? Fine. So far everybody is with me. So, what are the angles alpha, beta, gamma? So, this is 90 degrees, alpha is 90 degrees, beta is 45, gamma 45. Okay. So, we have all the ingredients. Now, you have to just cook your food. So, just get your equation. Okay. So, we have alpha, beta, gamma, and you have, in fact, only one u1 vector. So, you do not need to worry about u2, you just worry about u1, and equations are here, u1 minus 1. Now, you can just read off from here. Okay. So, this is sin other two angles. So, for this actually there is a rule which I written in the book. So, this angle minus this angle. Okay. So, both are 45. So, in fact, u1 dot of minus 1 is 0, sin 45 minus sin 45 is 0. And what is u1 of minus 1? I just wrote is minus a root 2 by I. So, dot of this. So, that means a dot is 0. Okay. So, it is easy, right. I mean, once we have this equation, then it is straightforward. We can work out for the other one, u1 0 1. Now, there are, so this is 0 1 I am talking about. So, the angle is the back angle minus front angle. So, back angle is 45, front angle is 90, and the dot u1 star u1. Okay. and so this is, you can just do this algebra, just copy from the equation, and now I know these objects, right, these objects are known. So it is a root 2 by I and c and so on. So just plug that in, and then that gives you this. Okay. So you have to just plug in. So u1 dot is 0 1 is what? 0 1 is, so I don't know, go back. What is 0 1? Can you see, right? C or minus C? B dot, and this is minus C dot. Okay. So you want me to work it out, but you can just do it. Okay. So I will not do this algebra. So this is what we got before, and we can do with the Crea-Haring in basically one page, right? I mean, this, once you have the triangle, this triangle, put in numbers, you do this, and we can work out more complex examples. So this for 2D field, you can work out for 3D fields. Okay. Now I will give some homework, maybe slightly difficult one, and you can work them out. Okay. So thanks.